Alrighty, afternoon everyone. Here's a short lesson on more operations with radials. Alright, the first thing we're going to talk about is adding and subtracting radicals. Okay? Now here's the first rule. In order for you to be able to add or subtract radicals, not only does the index have to be the same between the two radicals, but the radicands of the two radical expressions must also be the same in order to add or subtract those two expressions. Okay? Great. Now, all you do is just add the coefficients of each radical in order to combine them. Alright? Now again, remember, radicals pretty much behave like a variable, right? When you add variables, you can only add like variables, and we add their coefficients, right? So let's take a look at an example of what I'm talking about here. It says add 7 times the square root of 5 plus 4 times the square root of 3 minus 11 times the square root of 5. Well, if you notice, all three of these radicals have the same index, and all three of these radicals have the same radicand. Because of that, I know I'm allowed to add the three radicals. To do so, I just add the coefficients. Well, the coefficient of the first radical is 7. The coefficient of the second radical is 4. 7 plus 4 is 11. And I keep the radical the same. So 4 cube roots of 5. Now, minus 11 cube roots of 5. Well, 4 cube roots of 5 minus 11 cube roots of 5 is negative 7 cube roots of 5. And I've just added subtracted radicals. Okay? Take a look at the next problem. Now, in the next problem, I've got square roots. Well, this radical's index matches this radical's index, but it doesn't match this one. I know, faux show, that this first radical and the second radical cannot ever add with this third radical. Now, can I add the first and the second radical? Well, this radicand is 18, and this second radicand is 50. So at first blush, it looks like we can't add them. But don't forget, you might be able to simplify the radical. So if you take a look at this, the square root of 18, does he have anything square rootable? I'm sure he does. He's got a 9. Well, the square root of 9 is 3, and 3 times 5 is 15. So I'll get 15. What's left? 2. So 15 radical 2. Let me show you the work out there, right? So, all right, now look at 50. With 50 has the square root, the perfect square of 25 in it, times 2. The square root of 25 is 5, and 5 times 4 is 20. Square root of 2. Minus, when I simplify this radical, and again, you always want to try to simplify the radical. Well, 16, I'm looking for groups of 3 in this one. Well, 16, if you think about it, if you broke them down, it would be 2 times 2 times 2 times 2. I got 4 2's inside of him, so that will become, well, this group of 3 2's can come out to become 2 times the cube root of 2. Now, which radicals can I add together? Well, I can add the first and the second one together because they have the same index and the same radicand. So 15 plus 20 is 35 radical 2 minus 2 cube root of 2. Now, can I go further? Can I actually subtract 35 radical 2 minus 2 cube root of 2? No, I can't. Because of this index 3 being different from the index of 2, you're done at that point. You can't subtract anymore. Okay? I know you want to, but you can't. So don't try. All right. In example C. All right. Well, I've got the good thing is they're all cube roots. All right. So hopefully I can put them together. But the radicands are all three different. Well, let's try and simplify this. Well, we just did 16. 16 was 2, 2, 2, and 2. There are 4 2's in there, right? You know, this one group of 3 2's can come out as a 2. And that 2 will multiply by the 3. So I'm going to get 6 cube root of 2. Minus, when I break 54 down, and using my tree, I get 3 times 3 times 3 times 2. Well, again, I've got a group of 3 3's. Those 3's will come out as a 3, and 4 times 3 is 12. So I get 12 cube roots of 2. And then plus, well, when I break down 128, well, golly, that's just a bunch of 2's. That's 2, 2, 2, 2, 2, 2, and a 2, right? All right, now there's 7 2's in there, right? Well, I can take out one group of 2's and another group of 2's, so I get 2 2's. So that's 4 times the cube root of 2. Well, voila, look at that. All the indices are the same, and all your radicands are the same. So I can actually combine all three of these terms to get one single term. And I get 6 minus 12 is negative 6, and negative 6 plus 4 is negative 2 cube roots of 2. Okay, that's how we add and subtract them. Okay, the next thing we're going to do is just multiply binomials. Now, to multiply binomials, again, we're going to FOIL like we've done with variables. Because again, don't forget that radicals behave like variables. So if I have radical 2 plus 3 times 5 minus radical 6, all I'm going to do is distribute the radical 2 to the 5. 5 times radical 2 is 5 radical 2. Remember, numbers outside the radical cannot work with numbers inside the radical. And then radical 2 times radical 6 is, well, positive times negative is negative. And this time they can work together. 2 times 6 is radical 12. Since they're both inside a square root, they can actually multiply. Now I'm going to multiply the 3 and the 5 and get plus 15. And the 3 and the negative radical 6 and get negative 3 radical 6. Okay? Now, of course, we know whenever we FOIL, we try and simplify anything we can. Well, the 5 radical 2 doesn't combine with anybody. But I noticed that this radical 12 can simplify. Doesn't it have a perfect square of 4 in it? So I can pull the 4 out as a 2, square root of 3, plus 15 minus 3 root 6. Now, I just check. I know I've got some square roots going on. Do any of the radicands match? The 6, the 3, or the 2? None of those match, right? So you cannot combine any more terms. So this is just your final answer. Okay? Great. And the last type of idea that we want to look at is rationalizing the denominator. Now, we know that we can't have a radical in the denominator of a fraction, but we can't get rid of it. The best we can do is move from the bottom of the fraction to the top. Well, again, this is where we use our old friend, the conjugate, to clear the radical. If I have 2 minus radical 7, to get rid of that radical on the bottom, I'm going to multiply by 2 plus radical 7. Okay, and then I'll multiply the top by 2 plus radical 7. Okay? Now, in the numerator, we just distribute the 5 and get 10 plus 5 radical 7. And in the denominator, when we FOIL this guy out, I'm going to get 2 times 2 is 4. Plus 2 radical 7, minus 2 radical 7, and then positive times negative is negative. And radical 7 times radical 7, isn't it just 7? All right? Now again, if you notice, whenever we use the conjugate, doesn't the two middle terms cancel? So I'm left with, I'll come over here and do it, 10 plus 5 radical 7 over, well, 4 minus 7 is negative 3. Then I'm going to bust him up into 2 different fractions. All right? And I'm going to get, here, where can I put this? I'm going to move this up here a little bit, okay? This becomes negative 10 thirds minus 5 root 7 thirds, okay? And that is how we rationalize that denominator. Okie dokie, hope that was short and brief, 8.5 minutes, huh? Pretty good. I'll saw y'all later, Lauren.